Great to see you in Mehmet's presentation. Talked about the relationship with Siemens, and I'll echo that partly in what I'll go through this morning. So I've titled this presentation, Building the Digitalisation Talent Pipeline, and I'll take a slightly different view than I may have done previously with some of these presentations, but I'm aware there's colleagues who may have heard me talk before and some that haven't, so I'll try and hit the middle ground a little bit. In this presentation, I'll start off by talking about digitalisation, and I'll talk about Siemens' view of how important we see that and the impacts in industry, and probably more beyond the impacts in industry, more relevance to ourselves and the relationship with Middlesex is the impact that has in skills in the academic sector and the importance really of that. In the second phase of this, I'll talk a little bit about the next big thing, and you will all know what I mean here. I won't say until the last minute, but there is a huge wave of technology that is about to hit, and that is hitting already. It's already been touched on this morning, but I think that is going to have a huge impact over the next few years. I'll then go on to talk about collaboration and how important that is for us, the collaboration between academia and industry, that on both sides that has huge value beyond just our sectors for the global economy. I'll talk about the importance of collaboration. And then finally, I'll try and bring that together to talk about talent pipelines. And that's really the impact and the fruits of that partnership is the talent pipelines that it enables us to create. And I'll talk about some of the innovative approaches that we've taken alongside with Middlesex as one of our key partners in that journey. So I'll start off by setting the scene a little bit to start off with by talking about skills and digitalisation and how important they are and how they've shifted over the past sort of 5-10 years. And then I'll make a slight departure from this in a moment. But the starting point really of connected curriculum was the impact that we see digitalisation having in industry. And our colleagues here, our technical colleagues here at Middlesex University are very familiar with that. And we've seen a huge impact in industry over the past 5-10 years. And by digitalisation, just to sort of like set that common understanding, what we mean and what I mean by digitalisation is having a digital thread flowing right the way through every stage of that design, manufacturing and supply chain. So every part of that technological and engineering journey, having all of that digitally interlinked together. So you have the same digital thread that flows through those stages. Commonly done using digital twins, where you would combine the real and the digital worlds. We've seen a huge impact of that in industry. We see where companies adopt that kind of digital approach. They are very forward thinking and able to drive efficiencies in their business. And as well as the technology having changed over the past sort of 5, 10, 15 years, we see the skills that are required for that sector have also changed. And bringing that together, bridging that gap is absolutely crucial. We see partners such as Middlesex who've made great strides in that and produced some excellent graduates. A lot of what Mehmet talked about before in terms of the alignment between Middlesex and industry, I'll echo in this, and some of the great work that their students do, I think I'll also cite in this discussion. If we take a step back and we look at the global picture of skills and the impact of that, we see a huge and growing skills gap. And you'll hear this being reported across industry partners. And you've probably heard it for a number of years, that there is that gap between what academia can produce, the volume and the suitability of those skills compared to what's required. And that gap has continued to grow over the past decade, really. There is a double impact of that. And when I talk about that skills gap, I mean at the sort of higher level in terms of those skills, and particularly at the industrial readiness of those, the production of academia ready for industry, that skills gap. There is another impact of that though, and maybe an obvious one really, is that it's crucial for industry to be able to leverage digitalisation. It's crucial for them to be efficient, and they are hugely competitive. Every company is trying to squeeze out the last piece of efficiency in their business model. To be able to do that, they need to have a very agile and very capable business model. It needs to be digitalized. You need digitalization to integrate all those different parts of that business to drive efficiency in what they do. And the people who leverage that the most are the ones typically who will overcome those challenges and become globally dominant. So there's a real importance for industry to leverage that technology. They can't do it without the skills. So if they can't get the skills to help them do that, there's a huge impact for them to be able to adopt those technical skills. I then want to take a little bit of a step back and look at how digitalization has evolved over the past decade. The seeds of that are very well known and are sowed from academia. So academia did all the clever work in the background to be able to enable digitalization. But I think it's true to say that industry has been the partner that has really accelerated that development and made that possible. So they've taken these techniques and then utilizing them to drive efficient approaches. So for instance, virtual commissioning, which you may well be familiar with, a very forward-thinking approach and an ability to test things in the digital world using digital twins before you build anything. But largely this technical evolution has happened through industrial need. Industry needed to be able to do these things efficiently and therefore develop these processes to be able to do it. So it was the tool set that I think has really leveraged that. Not so much an academic development, more an industrial development. And the whole digital twins, and we've got a couple of different Siemens technologies being demonstrated here. But that evolution, I would say, has largely been led by industry in the past sort of 5-10 years. And there is some gap in some academic institutions of not really understanding how these tools have moved forward. Others there are, and Middlesex are one who are really on top of this, and you'll probably see that a little bit later on. But that development came through industry, not really from academia. So what is going to happen next? What's the next big thing? Well, digitalization, having everything digitally interlinked is really important, obviously, and sets the scene for AI in industry. And AI has had a huge impact already, but most of the impact of AI has really been in the commerce, in the IT world so far. It's had less of an impact on the OT world, and that is about to happen. And my view of that is that it's easy to get IT to write documents. There are low risks with that. And it's easy to get IT to, networks to produce videos and pictures. Again, it's low risk, but to get them to control something or to design a really critical part, that's quite high risk. You don't want an AI bot controlling a nuclear power station unless you're 100% sure it's going to work. So that sort of OT, IT impact, I think, has been a little bit more cautious, but we will see that happen over the next few years. But digitalization obviously is absolutely crucial for that. You can't do all these things and can't leverage the technologies of AI and the opportunity it provides without having that digitalization backbone, without having everything in a digital realm to start off with. So digitalization is absolutely key for the new introduction of AI, which is happening at the moment. So Siemens are developing lots of things that have already come out from Siemens, and there is more stuff about to happen as AI really gains pace. I wanted to show this briefly. It's you may well be very familiar with this, and this shows the developments of AI over the past sort of like 20-odd years. But it's really marked because you can see that, okay, AI has been around for a long time, and it's developed very much from an academic point of view, but it's only in the past few years that has really gotten the pace and been able to evolve enough to be really useful and to be taking that mass adoption. And that process is just about to accelerate, I believe, and what I think we'll see in the next few years from an industrial point of view. So fascinating times. If you're as interested in AI as I am, I'm fascinated every week to see what the next development is, and the impact in industry is just about to happen. So really exciting times. The other thing I think that is particularly interesting about AI, I call here the event horizon. And what I mean by that is that the ability to know what's going to happen next, our view, how far in the future you can look, I think is only really short. And I said before about me being excited about what's going to happen literally every week in it, because things are changing very quickly, and you can't predict what it's going to be like in 2 years' time, a year's time, 6 months' time. It could be a huge impact in terms of AI. So the event horizon, our ability to see to that horizon what's going to happen next, I think is really short. And I think that creates some really important and interesting aspects. One of which I think it is in terms of collaboration. I talked before about some of the approaches through digitalisation having come from an industrial point of view. I think it's really hard to know what's going to happen next with AI, where that development is going to come from. Is it going to come from industry? And it may well do, because the technologies here are already born, aren't they? It's really about integrating those into industrial tool sets. That's the next bit, and that's what's happening at the moment. We've got this new technology, these new techniques, and people are now trying to leverage them. How can these be useful? So I think it's really interesting and really difficult to know where that's going to come from. Is it going to come from academia? Is it going to come from industry? And I think that's why I think it's really important that there is this close collaboration, that we continue to collaborate over this evolving time, because otherwise one will lose pace with the other and then we'll be playing catch up. So I think that collaboration is really important to be able to leverage. In terms of collaboration then, we talked, and Mehmet mentioned connected curriculum and how great that's been here. But I think the collaboration in terms of digitalisation and what we've managed to achieve through connected curriculum has been really important, and I think we've all done really well with that. I thought I'd spend a moment just to explain what connected curriculum is. Maybe some of you don't here. We tend to use, or one of the key elements we use is the Festo Cyber Physical Lab, and we use a piece of hardware made by Festo Didactic, and Mehmet mentioned that later on. It's also, these technologies are also integrated into the World Skills Competition. They use Siemens PLCs, which is part of what we integrate into connected curriculum. And then what we do is we provide our academic partners with our Industry 4 software stack. So we provide them with our software, our academic license of our software technologies. And then what we do is we apply this technology to that particular use case. So we show how these technologies can be used against that hardware platform. So we build different kinds of digital twins of that Festo CP lab, and we show how these technologies can be applied. We then also provide Siemens training through connected curriculum. So we train up our academic partners, and we do that fairly regularly. In fact, we do some we took before in London next week with another partner. So there's no point in us providing technologies unless we train people on how to use them. Through connected curriculum, then we also provide industrial case studies. So we show through industrial examples how these technologies are being used by companies to drive and to improve their bottom line, how they can be used to leverage their businesses. And then we also provide lecture content, which we take from across the different Siemens businesses. Siemens, as you will know, is huge, both as being very big, it's also very diverse, lots of different sectors that Siemens is present in, which is great. And we provide lecture content from across those different sectors. In terms of where we're at, we've been doing connected curriculum for 5 years, and Middlesex have been with us right from the very beginning. We started off with just 4 partners. We now have 19 different academic partners, and that will continue to grow over future years. But Middlesex have been really instrumental in helping us build that, and are still one of the leading institutions in terms of connected curriculum in general. One thing that connected curriculum has helped us do, it's helped us collaborate with our academic partners, and we've built some really close ties, and they are linked in many different ways in these relationships now, which is great. It has also given us the opportunity to innovate in how we work with the academic sector, and that's produced some really interesting outcomes. If we look at the evolution of connected curriculum and how it's evolved over the past few years, we started off with that pie as you saw it before, but then there's been lots of other ways that it's evolved. So we also provide curriculum and technical consultancy. So we sit on a lot of industrial advisory boards and support our academic partners. We also support staff in giving them direct suggestions and help work with them both on a curriculum and the consultancy technical planner. We do online workshops, and we have those every other month where our partners come together and we talk about the evolution of technology, and we talk about how our partners are adopting them and what the students have done and what we're going to do next. And they've been really useful. Through connected curriculum, we've built a network of internal experts. So we've bridged into lots of different businesses, and we built up a real community within Siemens and externally outside of Siemens, but within Siemens, an internal network of experts which we can go to if there's a particular challenge. It also means that we can be ahead of the curve, and these technologies are coming on, and I talk about AI, and we have lots of links, and we can use that to be able to gain access to some internal experts, which is really helpful. We've also done work on academic secondments. So I have academics that work with me fractionally, that come from academia and seconded into Siemens to work with me on connected curriculum. But we also have connected curriculum and Siemens staff that have gone externally from Siemens back out into academia. And Professor Ross Caddens is an example of that, where he is a visiting professor at Teesside University and has done a fantastic job. We also do direct student support. So largely it's a train the trainer model. So we train and partner with and support and interact with academic staff, but we also do it with students too. So we directly interact with students, and we do that through one of the initiatives which we call Connected Curriculum Live, which is where our engineers work directly with students on projects over multiple weeks. But we also do project work with those students. So we have students who work with Siemens engineers, and we support them on technical projects. We've built a community and a network of peer collaboration. So where we have very capable partners, will within our connected curriculum academic network, often will support other less capable partners, and there's lots of collaboration that happens between those partners, and that's really great to see that have grown, and is crucial really to the model, is having our partners that collaborate directly with each other. And then the last little bit that I'll talk about, and possibly most relevant to the title of this, is the talent pipeline initiative that we've built recently. We implemented this last year for the first time. So talk a little bit about talent pipelines. They are absolutely crucial to what we do. We talked about that growing skills gap and the need of industry to be able to gain access to skilled, industrial relevant talent. So talent pipelines are absolutely crucial. If we look a little bit at how academia typically interacts with industry from a recruitment point of view, when academia or industry are looking to recruit, they do so in a one-to-one relationship and like a transactional approach. So we have industry will approach academia or the other way around. So typically, like a careers fair, academia would invite industry in, and industry may come and have stalls in like a milk round model where they would talk about and try and advertise themselves to academia. So that's one type of approach. Also, sometimes you'll get industry will invite academia to come and talk, and they will do like a recruitment event at their own premises, and maybe a big employer would invite an academic institution to bring students to them. But there's this sort of like transactional relationship with one would invite the other to some kind of event. And although that is effective and is the obvious way to do it, there are some limitations that kind of approach creates. And what we did with connected curriculum more recently was try to create a talent pipeline based around connected curriculum. So we tried to use this relationship to see whether we can leverage that to address some of the challenges and some of the important topic of talent pipelining. And what we did last year was we created a competition with just our connected curriculum partners, and we invited students from those partners to submit projects based on Siemens technology. And then we presented those students at Transform. So every other year, Siemens has a big industrial trade fair. The last one was just the summer just gone. It was held in Manchester. We had between 4,000 and 6,000 industrial customers that came to that event, so they're very big events. And at those trade fairs, we have all our industrial customers, not aimed at academia, it's aimed at industry, it's aimed at us marketing Siemens and Siemens technologies to our customers. But we also profiled students from our connected curriculum partners and their projects at that event. So we had industry, we had academia, our academic partners, our industrial customers. And the whole point of that profile about profiling those shortlisted candidates was to try and link them in to our industrial customers, to try and create that pipeline of skills from our industrial partners, from our academic partners into our industrial customers. And it's helpful for our academic partners because it helps them gain profile. They can gain profile not just with Siemens, but also with our industrial customers, and there was a lot of that happening. But it's also important for our industrial customers. We talked before, didn't we, about how important it is for them to gain skills. So in our academic partners, they can drive industry skills in their institutions, and that's what we want to try and help them do, which enables them to gain greater profile as their students are more efficient and deliver better projects. But our industrial customers need to gain skilled talent, which means they can leverage these technologies to drive their business forward. The other thing that we aim to do through this initiative was not only just to raise the profile with our big customers. So Siemens has a lot of very big customers, the real sort of like big global customers, but it also has a lot of SMEs, and probably even the majority of our customers are actually SMEs who don't have the same profile as the big partners. So if Siemens puts an advert out, it will get sort of 100, 200 to 1 in terms of job adverts. We have a big presence because we're a big company, and when we put a job ad out, we get a lot of applicants, which is great. But our SME partners don't have that. And they really need those skills. They're trying to recruit, they can't get that profile. And it's really important that they gain that skilled talent. And we were trying to level that playing field a little bit to give them more profile with some of the great talent which our academic partners have. So we were leveraging our academic links that we built up through Connected Curriculum and beyond. We were also leveraging our customer base, which already exists and is pretty huge. It's some 80 billion pounds, something like that a year in terms of the turnover of Siemens. It's a pretty big company. But leveraging the convening power of Siemens, we have obviously having such a big presence and big partnerships, I mean, we bring those together, and we've not really tried to do that before. So here, this is slightly different than a typical recruitment pipeline where you have just two partners. You have the academic part, you have industry, and you've got the two are trying to bring themselves together. We have a third party here now, Siemens, who are trying to do this and use our convening power to solve some of these recruitment challenges. This was the output of some of those projects, and this was these are taken at Transform. First prize in the competition. You'd be not surprised at all to hear went to Middlesex, and a great project by one of the students, one of Mehmet's students, who did some fantastic work, Mohammed Shart, and showing some of his work there. But there was other teams also from Middlesex that were shortlisted. The gentleman there, top right, is RMD, so he's the managing director of Siemens Digital Industries in the UK. Talking to Middlesex, the gentleman bottom right there, talking to Lucy, is actually our CEO. So he's the CEO of the whole of UK, all the different Siemens businesses in the UK, smart industry, digital industries, the whole lot. He's the top man, effectively, in the UK. So we managed to gain some real great traction internally within Siemens, and also with our industrial partners there. So, and I think that provides us with a blueprint of how we can move forward, how we can innovate and solve some of these recruitment pipeline challenges going forward, which, as I mentioned before, absolutely key. So the next big challenge really is the AI talent pipeline. Can we support this? Because it's going to happen. It's going to happen very quickly over the next few years, like it has in the IT world. As we can solve and as we can utilize and apply these tools, this evolution of AI in industry will rocket and will be really fascinating. But it's the talent pipeline to support that, and that we will need to build pretty quickly. I think is going to be the real challenge. That was it from me. I don't know whether we're taking questions at this point or...
Yeah,